Hello, very good morning, students. Welcome to BYJU'S exam prep. Good morning, all of you. So, after a long time, we are now again meet for the next subject, that is theory of machine. So, before starting the session, to clarify from your end, my audio and video all good, all perfect, so that we can start off the session. Very good morning, students. कैसे हो? All good. Very good morning. चलिए, so today we're gonna start the next subject on the foundation, that is theory of machine, an important subject for the gate examination. And I'll be discussing the previous year weightage also. Also, I'll be talking about some important topics from where you are like from where gate examination topics is the gate exam, right? So very good morning. Please do clarify, कोई दिक्कत तो नहीं है ऑडियो एंड वीडियो पे? All perfect. चलिए, so let's start with the session, and and we'll be discussing from the very basic level, that is the first unit of theory of machine, that is your simple mechanism. Okay? Under this we'll be starting a very important discussion, that is link and kinematic pair. What is the meaning of kinematic pair? This is the basic understanding, and why we have taken this topic is for this is a foundation course, right? So always we need to build a strong foundation, then only we'll be able to analyze other topics. ये आपका बेसिक टॉपिक है, फाउंडेशन टॉपिक है, फ्रॉम वेयर other set of topics will be built up and your complete subject will be. Okay, so a free classes on YouTube platform, that is by. All right, so let me introduce about myself. My name is Suraj Gopi and I hope so everyone has connected with my Telegram also. अगर नहीं किया है, please do connect, because I'll be updating not many updates about the classes, right? और इसके अलावा we'll be talking about some important updates about exam schedule, exam notification, right? So I deal with all this subject that you are seeing on the screen. Okay, and this is my Telegram channel, that is Mechanical by Chali. So GATE 2024 result is already being announced. A lot many students have secured a good rank by using B reps, and all the students who have excelled. We are so proud that lot many collegiate rank here by our by. Okay, chali. Apart from this, on our app there is a on YouTube we're having this foundation course. On our app we are having the ground zero series 4:30 or 5:30 on daily basis from Monday to Friday, sometimes Saturday, Sunday also, right? So you can do attend, that is also one of the foundation courses, foundation ground zero series, where basic concept is questions. Okay, right. Now if I talk about the official syllabus of GATE examination, we are having the complete set of topics that you are seeing on the screen. अगर कोई doubt है तो please बताइए. Fun. Ah. So uh, on our GATE syllabus also, if I talk about the GATE syllabus, we are having this set of topics which is mentioned. Out of this topics, which topics are very important that you must not be skipping out, let us try to talk about that. If I talk about the previous 8 years of trend, we are having like 5 to 7 number of questions is asked in the GATE. 8 to 12 marks, uh, like this year we had 9 or 10 marks as a weightage of theory of machine. Last year it was around 8. So 8 to 12 is the range where you can expect weightage of this subject. And the important topics from where every time you are expecting from very important, that is vibration, simple mechanism that we are studying right now, velocity and acceleration analysis, gear and gate ring. These are some set of topics from where you are expecting every year a single question, every year from these set of topics. So that is the reason I've written these important topics, and this is a trend I'm seeing from the last 7 years, from 8 years, from 17 to 24. Okay, fine. And the textbooks that you can refer for your understanding, but I think so if you are following this, textbooks requirement is also not there, but still if you want to have some self-study resources, there's SS Ratan standard textbook, you can go for Norton also, and the PDF of this ebook is already shared on my Telegram channel. You can do download from there. Okay, chali. So now let's begin our today's session. That is, what is link? What is kinematic link? What is kinematic? So anyone who can do, let me know what is a kinematic link or an element. Now, whenever we want to transmit motion, you always want some relative motion between some part. Okay, so every part of a machine will always have some relative motion with respect to each other, right? And that part or that element is called as kinematic link. Okay, that part or that element as kinematic link. Let us take one example so as to have better understanding. Kinematic link of every part of the machine which is having some relative motion with respect to each other, then that part is called as kinematic link. Or let us take an example. Let us suppose I'm having a slider, the ground, and this. Now you can clearly see that there is some relative motion occurring between the ground and this block. Okay, due to this relative motion, we can say this is the ground will be considered as one of the link, and the block will be considered as the second link. So there will always be present some kind of relative motion, or जब भी relative motion present होता है, then that kind of different elements we call it as kinematic link. Very important statement that it is always necessary that link must be a resistant body. The link must be a resistant body so that it is capable of transmitting power from one element to another element. For understanding this, let us take one very basic example. You all might have seen a belt and pulley system. Let us suppose there's a pulley 1, there's a pulley 2, and we are connecting the two pulleys with the help of a belt. And this belt is very loose. Let us suppose the belt बहुत loose है. ठीक है, we are providing input to link number 1, that is the input wheel. Link number 1 पे या फिर wheel number 1 पे we are giving the input. There is an electric motor, and there is a belt which is very sagging in. It is not a complete tightened belt. So tell me, if you are giving input to pulley number 1, will there be any power transmission from wheel 1 to wheel 2? Yes, let us hear from your side. अगर हम लोग wheel number 1 पे input provide करते हैं, we are providing some torque by using electric motor, then tell me, are we able to transmit the power from wheel 1 to wheel 2? Answer is big no. क्यों? क्योंकि even though we are having a wheel, even though we are having a belt, because the belt is not a resistant body now. Body is a belt hai, it is not having some resistance. The friction is almost negligible, right? So there is not some relative motion between each other. So that is the reason we would say in this particular example, belt is not a link. Belt won't be considered as a link. But अगर हम same example लें, if I try to take one more example in which I am taking a very stiff belt and we are connecting the two wheels like this. Now in this case, the belt is quite stiff. In this case, if you try to provide input to wheel number 1, right? So definitely what will happen, because there is a resistance or we can say resistant nature of this belt. So whenever we are giving input to link number 1 or wheel, due to the friction, what will happen? There will be power transmission to the belt, and because the belt is having a stiff, or we can say there's a relation between belt and pulley number 2. So due to that resistant nature, we will be able to transmit power. So in this particular example, the belt will be considered. Okay, so it's very important कि कोई भी link will be considered as a kinematic link if that body is having a resistant nature, right? Then only we'll be having the power transmission from one of the link to another. Clear है? ठीक है? Fine. So it's very important. It is necessary for a link to be a resistant body so that it is capable of transmitting the motion or power from one element. That is the property of kinematic link. That is the property of kinematic. Clear hai everyone? Perfect. Very good. चलिए. So now let's talk about what are the different classification of links. What are the different classification links? How we can classify different, right? So there are three major classification of links. We are having a rigid link, we are having a deformable link, and having a fluid link. Type of classification: rigid, flexible, and fluid link. What is rigid link? Anyone? By the name itself, you must be able to answer to this. What is the meaning of rigid link? Rigid link का मतलब that link in which deformations are negligible. That link where deformations are negligible. Where the deformations are negligible, we can call this, or the deformations are very minute, or in microscopic level we are having the deformation, right? So that kind of link we can call it as rigid link. The best example that is, we can have crank, connecting rod, we're having piston. So these are the examples of the rigid link. Obvious बात है, ऐसा नहीं होता. मान लीजिए you're talking about a bike engine, right? You have started the bike, and while starting uh, the diameter of the piston was, let us suppose, 5 mm. Let us suppose it was 5 mm, right? But after traveling half an hour, the diameter of the piston used to 4.5. Not like this. Deformation is not happening. Okay, fine. So in rigid link, there is no deformation, or the deformations are very minute, or very the microscopic level will be having deformation. That kind of links we can call it as rigid link. The second one is flexible link. What is flexible link? इसमें deformations are not negligible. In this, the deformations are not negligible, but are permissible limit. तो इस केस में we can say of flexible link, deformations इसमें allowed हैं, deformations are allowed, right? But it is up to certain limit. Deformation इसमें allowed है, but up to certain limit. Can you tell me some example? Some example of flexible link. The best example of flexible link is belt drive. अगर आपने देखा होगा belt drive में, there is one end of the belt to be a tight side in nature, and one end will be having a slack side in nature. We have done the analysis of the belt transmission, fine, or pulley transmission. तो उसमें आपने देखा होगा, if I try to take one example over here, आपका the belt that we are, so this is input, and always a tight side and the slack side is always decided based on the your output link. Input के basis में, output के basis में have this. Okay, now what is happening is, on one side of the belt we will be having a tight side, क्योंकि देखो, this particular needs to be rotated like this. Let's say the tension over here is T1, the tension over here is T2. So definitely in this particular side will be having the tight side, and this particular side will be the, यहाँ पर आप देखेंगे, will be having slight elongation and we can say compression of the belt happening. That means there is some deformation happening, but that is certain limit. ऐसा नहीं, we can elongate up to any value. एक point के बाद what will happen, the belt will be break down, है ना, उसका एक threshold value, there is a permissible limit. So always remember that in flexible link, deformations are acceptable, but until certain limit only. Beyond that, we won't be considering that as a flexible, right? So belt drive ho gaya. We can say the example of a chain drive. We can take an example of or this one, rope drive. So these are all the examples of the flexible. Okay, these are all the examples. Now the next one, do it. We have understood what is a rigid link. We have understood what is a flexible link. Then what is a fluid link? Fluid link is nothing but when the power is transmitted when the power is transmitted due to uh, fluid due to fluid whenever we are using fluid pressure to transmit the power from one element to another element, इस टाइप के लिंक को बोलते हैं फ्लूइड लिंक. बेस्ट एग्जांपल इज हाइड्रोलिक रैम, है ना. बेस्ट एग्जांपल ऑफ दिस इज हाइड्रोलिक रैम. और वी कैन टेक वन मोर एग्जांपल एज हाइड्रोलिक brakes, hydraulic brakes. Okay, so let us take one example to understand this in detail. Now, if I say over here, if you try to apply some input force to this paddle, there's a paddle, right? So what will happen? We will be compressing, we'll be applying pressure on this side of the fluid. So due to this fluid pressure, what will happen? This force is being transmitted and we are pushing this paddle or this ram on the upper side and the output. Okay, so what is basically happening is we are using fluid as a link because it is able to transmit the input power to the output. It is able to transmit the input to the output. Power is being transmitted from the input link to the output via a fluid. So that is the reason we can call this as. Okay, fine. Understood. So these are the different types of kinematic links, that is rigid link, flexible link and a fluid link. चलिए अब आगे बढ़ते हैं and let us talk about what is the different types of relative motion. देखो हमेशा in the first statement of kinematic link we have seen that every part of the machine which is having some relative motion with respect to each other is known. एक और example लेते हैं. Let's say I'm taking my hand as an example. So if I say this hand, this is able to move like this. Even though it is not moving, I'm able to move like this. This is called as a kinematic. This is one link. This is another link. If I talk about fingers, fingers may be, this is one of the link, this is second link. Because we are having some relative motion. So wherever there is a relative motion with respect to each other, we can call that kind of links as a. Okay, fine. Now, we have seen what is a kinematic link. Yeah, we have seen what is the different types of link. Now let us talk about what are the different types of relative motion. Very important, क्योंकि relative motion ही एक ऐसा parameter है that we have introduced in the definition of kinematic link. Okay, now if I talk about relative motion, there are three major classifications of relative motion. One is completely constrained, sexually constrained, and completely. One is completely constrained, CCM. Second is sexually constrained motion, SC. Third is completely constrained. Completely constrained motion means here we will be getting the desirable motion. Desirable motion matlab, let us suppose there is one link. I'm applying some input and I want this link to be rotating like this. Okay. If by giving any input it is able to rotate like this, I'll be calling this as a complete constraint because we are always getting the desirable motion. But let us suppose आप इस पे force लगा रहे हैं, sometimes it is moving like this, sometimes it is moving like this, sometimes it is rotating, तो आपको desirable motion नहीं मिलता. So whenever we are having situation where we are not getting a desirable motion, that kind of relative motion we can call it as incompletely. Yeah. So in completely constrained motion, we get a desirable motion. Desired motion. But we get the desired motion. Clear? Understood? Fine. 100% we'll be getting a desired motion. मतलब कोई इसमें confusion नहीं हुआ. That means you are providing input और आपका output हमेशा a desired motion. That kind of as completely. इसको समझते with some of with one of the example. Now, just take a block. एक block को if I try to keep this block in a the block which is kept in a 3D. So tell me this particular block, ideally how many motions are possible according to the Cartesian coordinate system? According to the Cartesian coordinate system, tell me y x This is a body kept in a 3D. Now ideally we can say this because there is no restriction, there is no constraint, so this body will be able to translate along x, translate along y, and translate along z. It can rotate about x axis, it can rotate about y axis, it can rotate about z axis. So ideally a body, if it is kept in an open space, it can have 6 motions possible: 3 translatory motion and 3 rotational motion, right? Okay, but let us suppose I'm keeping this block, let us suppose I'm block like this, इसके बीच में now the same block, whenever I'm keeping this over here, it is only able to move up and down, or back and forth. So here rotation is not possible, but yes, we are able to have only 2 motion possible. One is in the y direction, second is in the z direction. So that means we have restricted, out of 6 we have restricted 4 motions, right? So here if I talk about completely constrained, a body is able to have a 6 motions possible. But let us suppose if I take this example, it is like this: there is a cuboid, the cuboid is having a rectangular slot. यहाँ पे एक rectangular slot है, and we are inserting a rod, or we can say a rectangular cross section rod, which is able to, okay, if I say this is link number 1, this is link number 2, so this link number 2 is only able to move in the horizontal direction. That means out of 6 motions, it is only always will be having 1 motion possible. So that kind of relative motion we can call it as complete constraint, okay, because link number 2 is only having 1 motion, that is translate along x. That's it. It's not even able to rotate, it's not even able to move up and down. Okay, so now we can say link number 2 is considered as a completely constraint. मतलब अगर मैं input force देता हूँ and that force is reaching link number 2, it will always be having this translate along x direction. ठीक है? Okay. So that is basically, we can call it as a completely, where you are getting 100% desired motion, 100%, or we can 100% constraint is restrict. Constraint का मतलब होता है restriction. Completely constraint मतलब constraint restriction. So we will be having completely constrained. The link will be able to move in only in one particular desired motion. That is called as completely, right? चलिए अब आगे बढ़ते हैं. Now let us talk about the second classification, that is successfully constrained. अच्छा इसमें एक और एग्जांपल ले सकते हैं. Let us suppose we are having a rod. डायग्राम आप ड्रॉ करिए. एक इस टाइप का, having some line, जैसे जिम के वो होते हैं ना डंबल्स, फाइन. एंड व्हाट वी हैव डिड, इसको मैंने इंसर्ट किया है इन वन ऑफ द बॉक्स में. तब यहाँ से आता है. इसका साइड व्यू दिखाऊं, देखो ये वही है आपका जो ये वाला सेक्शन है. So here we can clearly see that we are able to have only the rotational motion possible. Translated possible नहीं है, क्योंकि अगर मैं इसका साइड व्यू यहाँ पे ड्रॉ करके दिखाऊं, if I try to draw the side view of this particular thing, having like this, and we are having arrangement that is kept over here. inside a box. So that means you won't be able to see. So here we can see we are only able to rotate it like this. You won't be able to have a translatory motion. So I can, this is an example of a complete constraint. Example of a completely constrained motion. चलिए अब बात करते हैं successfully constrained motion. What is successfully constrained motion? In this case also we will be getting a desired motion, but here we will applying some additional boundary conditions. Some motion, the motion will be controlled by surrounding. Let us take an example. Let us suppose I'm having a piston लेते हैं and we are having the cylinder. We are having a cylinder and we are having a piston. So tell me, piston will be having how many motions possible? Pistons के कितने motions possible है? How many motions is possible for a piston? Quickly. Yes, how many motions is possible for the piston? Simple question. 2. 2. ये translate भी कर पाएगा and it can rotate also. It can have a rotation motion about its central axis क्योंकि cylinder होता है ना, it can rotate inside this and it can have a translate. Very good. But because of the introduction of the connecting rod, अब जैसे ही connecting rod हम लोग इसमें attach करते हैं, then what will happen? Where as soon as we are attaching a connecting rod with the help of the gudgeon pin to the piston, we are eliminating this. हमने rotation part को remove कर दिया. So due to the connecting rod, presence of the connecting rod or the inclusion of the connecting rod, we are eliminating one of the motion. Now this piston is able to have one sliding motion. तो अब हम लोग बोल सकते हैं this is the side motion or complete, or we can say it is able to get a desired motion. Okay, fine. And that kind of relative motion we can call it as successfully constrained motion. Successfully means पहले ये unconstrained था, but because of some additional or surrounding conditions, it is converted into a constraint. That is the reason we can call it as successfully. ठीक है, एक और एग्जांपल लेते हैं, सबसे बेहतरीन एग्जांपल ये वाला एग्जांपल. मान लीजिए there is a rod, and this rod is inserted. अच्छा इसको क्या बोलते हैं? Draw the diagram first. इसको we have inserted inside a slot. Slot के अंदर हमने इसको, right? So inside this slot, can we say this yellow color shaft will be able to have a, can say translatory as well as a rotational motion? दोनों possible है. It can move up and down also and it can rotate it also. दोनों कर सकते हैं. तो अभी तो this is a unconstrained motion. But because of the introduction, if I'm applying a force, always if I try to apply a force over here, we are eliminating this sliding motion. So अगर sliding motion eliminate होगा, now we are only left out with rotation motion. Now we are getting a desired motion. Okay, so we can say in successfully constrained motion, the motion is controlled by surrounding because the force is present. Force के present होने की वजह से this we are able to eliminate the undesired motion. We are only getting the desired. This kind of as successfully constrained. And what do we call this type of arrangement? ये कहाँ use होता है? You might have seen this. This is bearing. Fine, journal bearing. An example of a journal bearing. तो आप machine पढ़ेंगे, right? Clear? चलिए. Now let us go to the third category, that is incompletely constrained. By the name itself, you can clearly say we are getting undesired motion. Undesired motion. In this case, if you try to give input to the system, we won't be getting a desired motion. Okay, it does not provide the desired output. This kind of completely. Best example है अगर we are inserting a rod. Sorry. box है, we are having a circular slot and we are inserting a rod inside the circle. Now what will happen, this rod will be able to rotate also and it can translate also. So here we are not getting any desired motion. तो इसी को हम लोग बोलते हैं, इसी को हम लोग बोलते हैं, क्लियर है? अंडरस्टूड? डाउट है? Done? Understood? The three categories, the three different types of relative motion that we have seen, that is complete constraints. इन दोनों में हमें desired motion getting desired motion, but in completely getting undesired motion. And make sure I'll be sharing this PDF now. आप इसको for a reference, for revision, you can do download this. Right, so now we can say in this particular diagram, just clearly visualize that this is an example of a completely constant motion because it is only having a translate. This is incompletely constant motion because it can have a rotational as a, but here because of the presence of flange, it is only able to rotate up and inside when the sliding motion flange की मदद से will be in attaching a flange to this pink portion. क्या होगा? It won't be inside or outside. That is example. Sexually constrained. चलिए अब हम आगे बढ़ते हैं. Let us talk about the pairs. Very important. You have understood what is the link, individual links, और हर links के बीच में relative motion होगा. We have seen the concept of relative motion. Now we have to understand that how two links are connected with each other. What kind of relative motion is present in between links? That is, we can call it as a kinematic. What is a kinematic pair? Kinematic pair means whenever two links are connected, okay, whenever the two links are connected, such a way that there is always be having a constrained motion between the two links. अगर दो लिंक कनेक्टेड है और दो लिंक्स के बीच having constrained motion का मतलब desired motion is possible, that kind of pair we can call it as kinematic. Okay, so any connection between two links is always called a joint or a pair, but this pair will only be called as a kinematic pair when the relative motion between the link is constrained motion. Now you will be able to understand each and every term because हमने each and every पढ़ लिया है. We have studied what is different types of relative motion, what is the meaning of constrained motion that we have. Okay, so kinematic pair क्या होता है? Two links when they are connected together, right, and they will always be having some relative motion, and if that relative motion is a constrained motion, that includes both completely constrained, या फिर successfully constrained, both, दोनों included है इसमें. Successfully, this kind of pair we call it as kinematic. अब kinematic pair को we have classified into different categories. Kinematic, right? हो गया? Please do confirm. Clear now? Yes, Akhilesh. ठीक है. So according to the type of relative motion, we can classify. The first category is the turning pair. First category is turning pair. What is a turning pair? Turning pair, also known as revolute pair or pin joint. In this case, what happens? Between two links, we are having a pure turning motion. Pure turning. This kind of pair we can call it as a turning pair. तब इस तरीके से एक लिंक यहाँ पर है और यहाँ पर पिन जॉइंट और दूसरा. This is link 1, this is 2. When the two links are connected with help of a pin, तो यहाँ पे आपको एक pure turning motion, डिजाइन मोशन हो गया. पॉइंट के अबाउट बात करूँ, it is always rotating about like this. an example of a pure, we can say turning pair or revolute pair or pin joint. Turning pair, revolute pair or pin joint. This is clear? Yes, Akhilesh, done. ओके, पिन जॉइंट भी बोलते हैं आपको, रेवलेट जॉइंट भी, रेवलेट पेयर भी बोल सकते हैं, और टर्निंग पेयर वी कैन कॉल इट एज अ टर्निंग पेयर आल्सो। डन। चलिए, सेकंड कैटेगरी इज स्लाइडिंग पेयर और प्रिज्मेटिक। सेकंड टाइप according to the type of relative motion is sliding pair or the prismatic. What is a sliding or prismatic pair? Between two pairs we are having pure sliding motion. जब दो links के बीच we are having pure sliding motion, that kind of pair we can call it as a sliding pair, something like that. पहले ही इसको example already we have seen. Let's say this is link 1, this is link number 2. Now between link 1 and link 2, there is a pure sliding motion present. So that kind of pair we can call it as a sliding pair or a prismatic. Okay, the relative motion is pure sliding. The previous one, the relative motion is pure turning. All right, चलिए, third type, that is rolling pair, very important. अब बिफोर अंडरस्टैंडिंग द रोलिंग पेयर, पहले हम लोग ये देखते हैं प्योर रोलिंग मोशन होता क्या है. व्हाट इज प्योर रोलिंग मोशन? वन, व्हाट इज द कंडीशन फॉर प्योर रोलिंग मोशन? व्हाट इज द मीनिंग ऑफ प्योर रोलिंग मोशन? लेट अस ट्राई टू अंडरस्टैंड दैट, फिर हम लोग इसको रोलिंग पेयर पे देखेंगे. प्योर रोलिंग मोशन मीन्स देयर इज नो स्लिप कंडीशन. Pure rolling motion means there is no slip condition at the point of contact. What's the meaning of this? Let us say there is a body, we are going pure rolling motion. It is ing also and it is also translating. Let us, this is the point of contact A. So at point A, at point of contact, we can say r omega will be in this direction and v will be in this direction. So at point of contact, as there is no slip, velocity at point A must be equal to 0. So r omega is equal to v. So this is the condition for pure rolling. Because at the point of contact there is no slip condition, that means at point A there must not be any velocity, so v must be equal to r omega. So this is the condition. Now coming back to our discussion, between two links, if you are having a relative motion which is pure rolling, that kind of pair we can call it as a, अगर दो links के बीच pure rolling motion होता है, that kind of pair we can call pure rolling. Understood? Clear है? डाउट कोई दुविधा? चलिए, next is the screw pair. Fourth one, that is a screw pair. Screw pair means just like a nut and bolt system. Screw pair means we'll be having threads. Threads will be present, and we'll be having this is an example of a screw pair where we'll be having a nut and bolt arrangement. This kind of pair we can call here. Understood? Screw pair. So we can say we can define it when the relative motion over the thread. The relative motion is over the thread. This kind of motion we can call it as a screw pair or nut and bolt arrangement. Understood? Yeah. अब इसमें ना एक बहुत इंपॉर्टेंट चीज आगे कल देखेंगे. tomorrow will be not tomorrow, on Thursday we'll be discussing about degree of freedom. और वहाँ से क्वेश्चन आते हैं. You take any exam, name any examination, they are always asking at least one question from the degree of freedom, 1 marks question. कल discussion importance some special cases. कल नहीं परसों. Now let us take one example. Let us suppose we are having, well, like, you guys gonna tell me what is this called? Comment section में बताइए. What is this diagram that you are seeing on? What is this called? What? An example of a ball bearing. Ball bearing example है. Fine. Where we can call this as an inner race. Very good. Call this as inner race. इसको बोलते हैं outer race. और इसको बोलते हैं आपका ball bearing. So let's say this is link number 1, this is link number 2, and this is link number 3. That means inner race is link number 1. Inner race is link number 1, outer race is link number 3, and ball bearing is link number 2. So tell me, between link 1 and link 2, between 1 and 2, what kind of relative motion is present? बताइए. Between 1 and 2, link 1 और link 2 के बीच किस टाइप का relative motion? Quickly. तो जितना हमने पढ़ा है, we have studied turning pair, we have studied the rolling pair, we are studying the sliding pair, we have studied the screw pair. So tell me what kind of relative motion is present. फिर अब सिर्फ इन दोनों को देखेंगे. देखो ये basically this is having a motion like this, right? Fine. Point contact है, that is according to type of contact, but I'm talking about what kind of pair. तो अगर आप सिर्फ इन दोनों को देखेंगे, आपका inner race है, आपका ball bearing है, तो ball bearing ऐसे rotate कर रहा है ना. So we are having a rolling pair between link 1 and link 2. We are having an example of a rolling pair. Roll कर रहा है ना, ये 1 के ऊपर वो roll कर रहा है. Yes. Between 2 and 3, link 2 and link 3, what kind of pair we are getting? क्या हो रहा बताइए. Between link 2 and link 3, again we are having a rolling pair. Tell me, अगर मुझे 1 and 3 के पीछे बताना है, between 1 and 3, 1 यहाँ पे घूम रहा है, 3 यहाँ पे घूम रहा है. What kind of pair? So here we are not having any rolling connection. Here we are having a rotating bodies. That means we can say this is an example of a turning pair का example. Turning pair में यही होता था. देखो turning pair में क्या होता है, या revolute pair में क्या होता है, we are having a rotational motion. Rotate करता है. So in this example they are rotating. So here we are not having a rolling pair. This is a rotating pair or a revolute pair. We can call it as a turning. Clear? Fine. अब clear हो गया. Kinematic pairs, different classification. एक और classification. Let us try to take the last one. That is a spherical pair. E. Spherical pair also known as ball and socket joint. Ball and socket joint. Example देखते हैं. You might have seen bike का जो rear view mirror होता है. देखा है कभी? करके होता है ना, बाइक्स में लगा होता है. यहाँ पे ऐसे, यहाँ से आप बैक साइड देख. So you can rotate that mirror in all the 360 degree of direction. So whenever we are able to rotate in all the 360 degree of direction, that is we can call it as ball and socket joint. Best example is rear view mirror of the bike. Okay. या फिर आप शोल्डर भी जैसे देख सकते हैं. शोल्डर आप आराम से you can rotate 360 degree. There is no restriction. है ना, आप आगे पीछे आराम से इसको मूव करा सकते हैं. So you can say this is an example of a spherical pair or ball and socket joint. या आपने जॉयस्टिक देखा होगा. अब आप जब गेम खेलते हैं तो जॉयस्टिक होता है. जॉयस्टिक यू आर एबल टू रोटेट लाइक दिस, ऐसे करके होता है ना. यू आर एबल टू रोटेट दिस इन कंप्लीट 360 डिग्री, ऐसे करके आप मूव कराते हैं. सो दैट इज एन एग्जांपल स्फेरिकल पेयर और बॉल एंड. Okay, so this is the classification of kinematic pair according to the type of relative motion. ये सब के सब according to the type of relative motion था. Sliding pair or prismatic pair, turning pair, revolute pair or pin joint, rolling pair, screw pair, and the spherical pair. So 5 different types of pairs we have discussed in particular. Okay. Now let us talk about the second classification. Kinematic pair ko we can do classified in under one more category, that is your according to the type of contact. दो links के बीच में किस type का contact है? Between two links, what is the type of contact? The second classification. Here we can do classified majorly under two categories. One is lower pair, second is higher pair. Lower pair and higher pair. What is lower and higher pair? Between two links, whenever there is a surface contact, whenever there is a surface contact between the two links, we can call it as a lower pair. Example आपको देते हैं, sliding pair. We are having the turning pair. एक बार और बताओ. ओके, ठीक. स्फेरिकल पेयर देखो क्या होता है, इसमें क्या है, कोई ट्रांसलेटरी मोशन नहीं है. इसमें बॉडी, अब इसमें 3D में बात करें, इसमें बॉडी कंप्लीट 360 डिग्री घूम रहा है, पूरा 360 डिग्री घूम सकता है आराम से. जैसे आप बाइक का मिरर वाला देखते हैं ना, बाइक का जैसे आप पीछे की तरफ देखते हैं, ये ऐसे करके होता है, ये जो रॉड लगा होता है और यहाँ पे ग्लास लगा होता है जहाँ से आप पीछे. अब ये देखेंगे इसको, यू कैन रोटेट दिस लाइक, इसको ना आराम से आप ऐसे घुमा सकते हैं, ऐसे करके घुमा सकते हैं, ऐसे करके घुमा सकते हैं. तो दैट इज एन एग्जांपल ऑफ ए स्फेरिकल पेयर. ठीक है. या फिर जब कोई आप गेम पार्लर जाते हैं, तो वहां पर एक ऐसे करके बटन होता है, याद है, तो उस बटन को आप आराम से ना ऐसे करके घुमा सकते हैं. तो दैट काइंड ऑफ जॉइंट वी कैन कॉल इट एज अ व्हाट, स्फेरिकल पेयर. उसको बोलते हैं हम लोग स्फेरिकल और बॉल एंड सॉकेट. तो बॉल एंड सॉकेट जॉइंट भी बोल सकते हैं या स्फेरिकल पेयर. अब क्लियर हो अखिलेश? अंडरस्टूड? ओके, बहुत बढ़िया. अब आते हैं, लेट अस टॉक अबाउट द कॉन्टैक्ट. दो लिंक्स के बीच में किस टाइप ऑफ कॉन्टैक्ट. इफ यू आर हैविंग अ सरफेस कॉन्टैक्ट वी कैन कॉल इट एज अ लोअर पेयर. अगर हमारे पास पॉइंट और लाइन कॉन्टैक्ट है उसको बोलते हैं हायर पेयर. जैसे रोलिंग पेयर, पॉइंट कॉन्टैक्ट होता है, रोलिंग पेयर में पॉइंट कॉन्टैक्ट होता है. इसके अलावा वी कैन टेक स्क्रू पेयर. फाइन, एज एन एग्जांपल ऑफ दिस वन. इसमें आपका स्फेरिकल पेयर भी आता है, स्फेरिकल पेयर, सरफेस कॉन्टैक्ट. स्क्रू पेयर विल बी कंसिडर्ड अंडर द हायर. अब कभी कभी इसमें एक और कैटेगरी आती है, इसको बोलते हैं रैपिंग पेयर. रैपिंग पेयर क्या होता है, व्हेन वन लिंक इज बीइंग रैप्ड ओवर अनदर लिंक, मतलब एक लिंक को दूसरे लिंक के ऊपर रैप करते हैं जहां पे मल्टीपल पॉइंट कॉन्टैक्ट्स आते हैं, दैट इज वी कैन कॉल इट एज अ रैपिंग पेयर. एक एग्जांपल लेते हैं, लेट्स से देयर इज अ पुली और पुली अरेंजमेंट, बेल्ट एंड पुली वाला एग्जांपल लेते हैं, बेल्ट एंड. So here what we are doing, we are wrapping a belt, over here. तो अगर मैं इसका माइक्रोस्कोपिक व्यू अगर मैं यहाँ पे देखूं तो हो क्या रहा है, वी आर हैविंग अ पुली सरफेस, आपका पुली सरफेस है और इसके ऊपर आपने बेल्ट लगा रखा है. बेल्ट का ऐसे करके होता है, मल्टीपल पॉइंट कॉन्टैक्ट्स होते हैं, right? So whenever one of the link is being wrapped over another link and where we are having multiple point contacts, that kind of pair is called as a wrapping pair. और wrapping pair higher pair का ही एक एग्जांपल है, तो यहाँ पे मल्टीपल पॉइंट कॉन्टैक्ट. क्लियर? फाइन. आप बोलेंगे सर क्या स्लाइडिंग पेयर भी तो मल्टीपल पॉइंट कॉन्टैक्ट्स होते हैं. देखो स्लाइडिंग पेयर हम क्या बात करें, प्योर स्लाइडिंग पेयर. प्योर स्लाइडिंग मतलब फ्रिक्शन नहीं होना चाहिए. फ्रिक्शन नहीं मतलब आपका पॉइंट कॉन्टैक्ट वहां पे होगा ही नहीं, बिल्कुल प्लेन सरफेस, सो दैट हियर वोंट बी हैविंग एनी मल्टीपल पॉइंट कॉन्टैक्ट, सरफेस कॉन्टैक्ट. बट रैपिंग पेयर में अगर देखो यहाँ पे लेट अस सपोज यहाँ पे फ्रिक्शन अगर नहीं होता, लेट अस सपोज बिटवीन पुली एंड बेल्ट देयर इज नो फ्रिक्शन, देन वोंट बी कंसीडर्ड एज अ लिंक, क्योंकि तब उसमें क्या होगा, इनपुट व्हील विल बी रोटेटिंग एंड बेल्ट वोंट बी मूविंग, यहाँ पर कोई मोशन नहीं होगा। मान लीजिए ये आपका ये आपका व्हील है, इनपुट व्हील, ये घूम रहा है और इसके ऊपर बेल्ट लगा रखा है। बेल्ट और व्हील में इफ देयर इज नो फ्रिक्शन, तब क्या होगा, बेल्ट अपनी जगह पे रहेगा और व्हील घूमता रहेगा, देयर इज नो पावर ट्रांसमिशन। पावर ट्रांसमिशन के लिए फ्रिक्शन होना जरूरी है, व्हील और बेल्ट में फ्रिक्शन होना जरूरी, तभी अगर ये घूमेगा वो भी बेल्ट को आगे घुमाएगा, देन द बेल्ट विल बी एबल टू रोटेट लाइक दिस। तो यहाँ पे फ्रिक्शन होना जरूरी है, यहाँ पे पॉइंट कॉन्टैक्ट होना जरूरी है, इसलिए हम इसको बोलते हैं एग्जांपल ऑफ अ, दैट इज द रीजन वी कैन कॉल इट एज अ रैपिंग। ठीक है, fine. So these are the different types of discussion of the kinematic pair. So basically we can classify kinematic pair under two categories according to the type of relative motion, जिसमें turning pair, sliding pair, rolling pair, screw pair और spherical pair देखा। According to the type of contact we have discussed two major classification, lower pair and higher pair. Higher pair का ही एक special case है, that is this clear? Okay, fine. So ये आपका आज का discussion about the link and kinematic pair, right? So now we'll be meeting on Thursday. Now we'll be meeting on Thursday, same time, that is 11 a.m. and we'll be discussing a very important discussion about degrees of freedom. Questions यहाँ से पूछते हैं, right? So Thursday को मिलेंगे सुबह 11 बजे and in this degrees of freedom I'll be taking questions also, numericals भी लेंगे from the DOF, degree of freedom के numericals भी देखेंगे and to understand it more accurately. Clear? Okay, done. So that's it from my side, and let's have a quick update. Kal Richa ma'am will be coming up live and she'll be talking about the insider tips and techniques to crack gate 25, a live free interactive workshop. Along with that, if you want, because we have already started our vision gate batches for 25 and 26 in English and Hindi both, right? होगा ग्राउंड जीरो भी होगा, वो ऐप में होता है, वो 4:30 बजे या 5:30 बजे होता है, कभी कभी 4:30 बजे, कभी 5:30, वो आप शेड्यूल देख सकते हैं, ऐप को इंस्टॉल करके ऐप में अटेंड। इसके अलावा यूट्यूब में वी आर हैविंग दिस फाउंडेशन कोर्स ऑन यूट्यूब एंड ग्राउंड जीरो सीरीज ऑन आवर ऐप, फ्री क्लासेस हैं, 1-1 घंटे की क्लासेस चल रहे हैं, डू इट नाउ डेडिकेटली इफ यू वांट टू स्टडी आवर classes on our platform, we are having vision gate batches। और सबसे अच्छी बात क्या है, सर 2 मिनट काउंसलिंग वीडियो डाल, ओके फाइन। आप एक काम करिए ना, आप इसमें कॉल एक बार करके देखिए, तो वो डेफिनेटली आपको हेल्प आउट करेंगे, राइट? और या फिर आप मेरे को टेलीग्राम पे भी मैसेज कर सकते हैं, तो मैं आपका मैसेज सेंडिंग दैट, अगर आपको कोई इशू आता है। तो सबसे अच्छी बात, इफ यू वांट टू एनरोल टू दिस कोर्स, आप अप टू 90% ऑफ करा सकते हैं बाय अटेंडिंग दिस नेशनल स्कॉलरशिप टेस्ट, जो कि होगा 14th। ठीक है, तो आपके के लिए बोल रहा हूँ, कि आपके फायदे की बात बोल रहा हूँ, अटेंड दिस स्कॉलरशिप टेस्ट, आप अपना स्कॉलरशिप अवेल कीजिए बाय अटेंडिंग दिस स्कॉलरशिप टेस्ट, एंड यू कैन, इफ यू हैव एनी डाउट और डिफिकल्टी, यू कैन डू watch, call to this number, or you can do contact me on my, thank you Ahmed। क्लियर? और कोई डाउट है, कोई डिफिकल्टी है तो ज़रूर बताइएगा, मेरे टेलीग्राम चैनल पे आके यू कैन डू मैसेज। so that's it from my side, okay? so let's meet on Thursday 11 a.m. तब तक हाँ, जो हमने आज पढ़ा है तो थोड़ा समझिए, रिवाइज कीजिए, राइट? एंड आई बी शेयरिंग दिस पीडीएफ, अब मैं अपने टेलीग्राम चैनल पे ना को शेयर करूंगा, यू फाइन, ओके? सो थैंक यू गाइस, बाय बाय, टेक केयर, स्टे सेफ एंड एंजॉय योर प्रिपरेशंस जर्नी विद बायजूस। थैंक यू, बाय बाय। और अखिलेश सर के कोई डाउट है तो आप मेरे से डायरेक्ट कॉन्टैक्ट कर सकते हैं, ओके? चलिए, थैंक यू, बाय बाय।